Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad NABIL AIMAN by AHMAD KAMAL. So for my technical review presentation, I would like to present regarding my topic, which is swell noise attenuation. So basically this is my presentation outline, which I divide it into 7 parts. The first part will be the abstract of the topic. Next, for the introduction part, it will consist of definition of the swell noise. And then I will continue the presentation with objective, which is consists of 4 objectives. After that, continue with the literature review on this topic with some current issues. Finally, I will conclude my presentation is in the conclusion part with some future direction on this topic. So moving up to the first chapter of the presentation, which is the abstract of the swell noise attenuation. Basically, swell noise attenuation is the first step in the processing sequence of marine seismic data, and often this filtering requires a good amount of testing to achieve optimal result, particularly when swell noise characteristics vary considerably along the survey. In the context of onboard processing, this filtering is the bottleneck of the production sequence, and it will be very useful both technically and economically if there exists a solution that automates this process. There are a lot of methods that are being proposed in order to enhance the result of the seismic data after attenuation of the swell noise have been made. So this is some general information regarding the swell noise. Basically, I divided into 3 parts, which is the first one is what is the definition of the swell noise. The second one is why we need to remove the swell noise. And the third part is how we gonna remove the swell noise. And for the first one, the definition of the swell noise can be defined as a high amplitude noise that normally contains frequencies ranging from 2 until 10 Hz. And it also can refer as a ground swell in the context of an ocean, sea, or lake. And why we need to remove is because it is to remove the unnecessary noise that can lead to wrong interpretation of seismic data. And the conventional method that being used to remove this swell noise is by applying the FX filtering to the frequency range, and also by detecting the high amplitude and mute them, and applying the FK filter or TP filter. There are 4 objectives in my technical review presentation. The first one is basically to analyze the main people working in this area. The second one is to identify the new advanced method proposed for the swell noise attenuation. For the third objective is to investigate the current issue on swell noise attenuation. And the last objective for this presentation is to show the significant gap between researchers in this topic, which is the swell noise attenuation. In order to complete my objective, I have done some literature review on 4 topics, which is the first one is the main people working in this area. The second one is basically the significant gap between researchers in this topic, and then the current debates on this topic, and also some recent major advance and discovery that have been made to attenuate the swell noise. This is some perspective view from the people that mainly working in this area. The first one is from the Albert in 2009. He said that the swell noise is the most dominant noise type on the raw marine short gathers and mainly originates from the rough sea state due to the weather condition which produce wind-driven longitudinal sea surface wave and can be regarded as a incoherent noise in marine dataset. And for the second people, which is the Brown and Clapp in 2000, to manage this problem, new techniques based on the noise estimation and separation strategies in attenuating of the noise have recently been developed and used by many researchers. And the third person is Campbell and Follett in 1995. He said that the conventional technique based on the frequency domain discrimination of the swell noise and primary reflections include the 1D high pass or low cut filtering, the band pass filtering, and the FK and FX filtering. And in 2008 and 2010, according to the Beccara and the Van der Baan, apart from this conventional method, they proposed that it also suggested an automatic technique for the detection of large amplitude noise, such as the swell noise, and developed an algorithm to suppress it in FX domain. For the significant gap in research, this slide will show you some different methods that have been developed by different researchers in order to overcome the problem in swell noise attenuation. Seismic noise attenuation has gone through a long history of development, and the straightforward method by applying the FX filtering to frequency range. But the noise amplitude can be high compared to the signal. Basically, this is the problem in the swell noise attenuation, and it will lead to unacceptable residual. And to overcome this problem, several researchers has come up with different methods. So this is basically the significant gap between research in order to overcome the problem. The first one is in 2008, Swell invented the improvement by applying the FX filtering iteratively. Later in 2010, Beccaro and Van der Baan continued to develop an automatic method where it can give the differentiate the statistical properties between the swell noise and signal amplitude. Later then, in 2015, Stanford's model coherent signal via its low-rank trajectory matrix, and their method basically can separate the signal and swell noise in corrupted input. In 1999, there are also some researchers that propose to use the Wiener prediction filter in order to suppress the swell noise. And this method basically used to estimate the swell noise embedded in the raw marine seismic data. After that, the predicted noise is subtracted from shots by a trace-by-trace basis, and the result shows that the deeper reflection shows have significantly higher amplitude and shows better trace-by-trace consistency in final migration. So basically, this is all the significant gap between researchers in order to overcome the problem that happened in the swell noise attenuation. So this slide will discuss on the conventional method that have been used to attenuate the swell noise, which is by applying the band pass filtering or BPF. And it is basically will remove the whole low frequency band of the spectral content. Thus will result in the total loss of the amplitude concerning the low frequency reflection from deeper reflectors, and hence lower the resolution in the deeper reflection events. And it is worked by computing the spectral estimate at each frequency. Later, it will be compared with amplitude that estimated of prism, good trace, and chosen window. So basically, this is the recent discovered method on the attenuation of the swell noise, which is the only two noise method. And the aim of this method is to capture only the swell noise pattern, and it will extract the swell noise rather than the clean image and attenuate it. This can be shown in the equation, which is the Fs in the bracket S plus N will result in the swell noise. Instead of the producing the clean signal, it will produce the swell noise, which is the N. And this method is using the deep learning based residual network. And the model design is basically from the ResNet components, where X is the original identity, Fx is stand for the residual, and Hx is stand for the final mapping. And the picture in the slide shows the some mechanism of the only two noise method, which is how to produce the denoise image by subtracting the corrupted image with the extracted swell noise, and we result to the denoise image. The second recent discover major advance and discoveries in attenuation of the swell noise is basically in the paper called the Toward Automatic Swell Noise Attenuation. Basically, this method is improving the detection of the swell noise. It's a way to improve the filtering performance. And this method is proposing a solution based on deriving a global FX signal mask for each gather. There are three advantages by using this method. The first one is basically the noise detection is done globally. And the second one is the global signal mask will lead to a better signal preservation as non-noisy traces will not affected by the filtering. The last advantage is there are possibility to adapt the spatial window size for the filtering as a function of the frequency for a better signal interpolation. So this is basically the two current debate that happen in the swell noise attenuation. It is between the two researchers, which is the first one is the Watts in 1999, and the second one is the Albert in 2009. Watts proposed that in his article, the time frequency denoising can somehow attenuate the swell noise, but for the Albert, it is contradicted with the Watts, where he examined on how the wavelet packet domain processing on swell noise attenuation. So this is the difference perspective between the two researchers, which is the Watts and the Albert. Basically, the swell noise attenuation has achieved many progression regarding the method, and this is some ideas on future direction where it can be continued in order to enhance result on the swell noise attenuation. The first one is the using of the new discovered method is a beginning of a new method that can help in the swell noise attenuation, and the development of method in swell noise need to be continued in order to overcome the problem in the swell noise attenuation, and it is to ensure to get the best method that can detect and remove unnecessary noise that can lead to the wrong interpretation in the seismic data. There are a few conclusions that can be made based on my technical review presentation. The first one is the paper proposed a deep learning model with CNN-based residual network for seismic swell noise attenuation. This can be looked from the proposed advanced method, which is the only two noise method, where it used the CNN-based residual network for their method. And the second conclusion that can be made is it can show the comparable result to the conventional method. The third conclusion is, based on the proposed advanced method, the swell noise can be detected and removed with mild primary hurt, and the written image shows a premium quality with limited influence on signal of interest. This is basically my reference list where that helped me in order to complete my technical review presentation. This is the end of my technical review presentation. With that, I would like to end my presentation with Assalamualaikum and thank you.